Discuss the work is of two types, expansion and compression, right? So now we are going to study the work is further divided into two types. Okay, so one is reversible. Okay, one is reversible, other one is irreversible. And I hope you people know the difference between what is the meaning of reversible and irreversible. Okay, so actually the reversible work done, whatever it is a hypothetical concept. It is a hypothetical concept, whereas this is what a practical concept. That means in reality what happened, in reality which type of work is there, irreversible work is there. Okay, reversible work is a hypothetical concept, right? So that means if sometimes in the questions if we didn't provide whether they are asking reversible and irreversible, they will just ask you to find out the work done. Then at that time you have to go with the irreversible work done, because out of two which one is the practical one, irreversible is the practical one. Okay, next, reversible means what? It will takes place in several steps. Okay, whereas irreversible, what happened? It will takes place in what? Single step reaction. Okay, now suppose if I try to draw the graph, PV graph. Okay, here also PV graph. Here also I'm going to take PV graph. Okay, now what happened here? Right, so this is a single step, means it should be like this. Okay, now here this is a minimum thing. Okay, since it is a several step, what happened? It will takes from here. Okay, now what happened here in this case? Right, so now what happened here in this case, you can see that some extra space is also occupied here. Okay, so generally what we can say, higher the area, okay, higher will be the work done. Higher the area, higher will be the work done. So from this what we can say, work done reversible is greater than work done irreversible. Okay, since here some extra area is occupied than the irreversible, so what you can say, work done reversible is greater than work done irreversible. Okay, you may get in the assertion reasons also. Okay, right, moving to the next one, formulas. So let us try to write down what is the formula for the reversible work done and what is the formula for irreversible work. Okay, for irreversible work done, there is one and only one formula, right? And that formula is nothing but W is equal to minus P delta V. Okay, W is equal to what? Minus P delta V. Whereas here, the first for can be given as W is equal to minus 2.303 nRT log V final by V initial, that is final volume divided by initial volume. Second formula, W is equal to minus 2.303 nRT log, opposite of volume is, since we know that pressure is inversely proportional to volume, right? So what you can write here, P initial divided by P final. Okay, so what you can say here, P initial divided by P final. Clear till here? And one more thing here, pressure, suppose the pressure units and volume units. Okay, suppose if you're taking pressure as atmosphere, okay, and volume as liter. Okay, so then remember 1 liter atmosphere, which is work done units, okay, can be equal to how many joules? 101.3 joules. Okay, or else you can write 24.2 calories. Next, if you're taking instead of atmosphere, if you're taking bar and liter combination, then 1 liter bar value can be equal to 100 joules. Clear till here? I hope you people understood. So all natural processes are irreversible process. Okay, so one more important point, so which is nothing but you have to write all natural process. What is the meaning of natural process? Falling of water from higher level to lower level, all these things. Okay, all natural process are irreversible. All natural processes are irreversible. Clear till here? Right. So now moving to the next one. The second concept, as I said, so let us try to understand what is the formula. First law of thermodynamics formula, delta U is equal to Q plus W. Right. We have studied the definition, everything regarding internal energy. Just now we have studied the work done, types of work done. Now we are left with what to study regarding the heat. Okay. So write on the next heading now, heat. Okay, generally heat is denoted by which letter? Q. What is the other name in heat? Heat is also known as energy. Okay, what is the heat? Can it state function or path function? Can I say it is nothing but our state function, sorry, path function, and extensive, intensive, or boundary means it is a boundary. Okay, if boundary option is not given, then you can go with the extensive. Okay, generally what is the meaning of heat? It is the energy. Okay, heat is nothing but it is a energy which flow from, okay, which flow from always flow from where? High temperature to low temperature. Okay, now this heat is further divided into three types. Okay, like the work is divided into two types, heat is also divided into how many types? Three types. What are those? Heat capacity. Okay, heat capacity denoted by the letter C. Next, molar heat capacity, okay, denoted by the letter Cm. Next, specific heat capacity denoted by the letter small. Okay, so detailed discussion regarding everything we are going to study. Where we are going to later we are going to study what is the formula of heat capacity, molar heat capacity, and specific heat capacity. Okay, now let us try to understand one more third concept, which is nothing but types of process. Okay, types of process. So let us try to write down the types of process. The first type of process is what? Isobaric process. Okay, what is the meaning? Whenever you see the word isobaric, what does it indicate? It indicates that bar units belongs to whom? Pressure. That indicates what? Pressure is not equal to zero, but change in pressure is equal to zero. What is that? Pressure is not equal to zero, but for example, when I entered the class, pressure is 1 atmosphere. When I'm leaving the class, pressure is 1 atmosphere. So now, can I say pressure is constant throughout the process? Right? Pressure value is not zero. Change in pressure. What is the change in pressure? Final pressure 1 atmosphere. Okay, initial pressure also 1 atmosphere. 1 minus 1, 0. Okay, so what is the meaning of isobaric process? Pressure is constant. Constant doesn't mean that its value is zero. Constant means, what is the meaning of constant? Its value is same throughout the process. Even after 5 hours also the value will be same. Okay, now let us see what happens to the in under the isobaric process. Let us see what happens to the work done. Generally, what is the formula of work done? Minus P delta V. Why I am considering this formula? Why can't I consider the reversible formula? Because all natural processes are irreversible. Which one is a practical process? Irreversible. So that's why I'm considering formula of what? Irreversible. Okay, so here delta P is 0. Who is 0? Delta P is 0. So do you have any delta P? No. So I have to do any change? No change. So in this formula there is no change. That means work done formula, there is no change in the work done formula under isobaric process. Okay, now let us see about second one, delta U. What is the delta U formula? First law of thermodynamics, Q plus W. Do you have delta P anywhere in this formula? No. That means what we have learned? We have learned that in first law of thermodynamics under isobaric process there is a no change in the formula. Clear till here? Right. In the same way, moving to the next one. Second one is isothermal process. Okay, so the second one is nothing but isothermal process. Okay, so generally what is the meaning of isothermal process? Isothermal process indicates what? Temperature is constant. Okay, that means delta T is equal to 0, but T is not equal to 0. For example, when I entered into the class, temperature was 25 degrees Celsius. When I'm leaving the class also, temperature is 25 degrees Celsius. So what happened? Change in temperature is how much? 0. But the temperature itself is a 0. No, so that means what is the meaning of temperature is constant? Its value is same throughout the process, but change is 0. Okay, there are few things you people have to remember whenever you see the isothermal process. The first thing you have to remember is what? Delta T is 0. The second thing you have to remember is delta U is 0. And the third thing is that delta H also 0. But these two are applicable only if the question is related to what? Ideal gas. Clear till here? Now let us see one by one. Let us see first of all for work done formula. What is the work done formula? Minus P delta V. Okay. So do you have delta T anywhere in the formula? No. So can I say there is a no change in the formula? Right? There is no change in the formula. Okay. Now let us see for the second one. What is the second one? Delta U formula. Delta U is equal to what? Q plus W. So can I say here even delta U is 0? Okay, for example, let this will take for ideal gas. Okay, the question is for ideal gas. Can I say for ideal gas delta U is 0. So now what you have to do, 0 is equal to Q plus W. So from here what you can write, W is equal to minus Q, or you can write Q is equal to minus W. Clear till here? Right, so this is nothing but whatever, this is nothing but isothermal process. Let us go with the next one, third process. So the third process is isochoric process. What is the third process? Isochoric process. Okay, let us try to understand what is isochoric. Isochoric indicates what? Volume is constant. That means what? Delta V is 0, but V is not equal to 0. Okay, what is the meaning of V? Volume is constant. When I entered into the class, volume was 25 ml. When I'm leaving the class, also 25 ml. That means there is no change in the value of the volume, but change in volume value will be what? 0. Okay, right. So let us try to understand one by one here. So here delta V is 0. Okay, what is the first formula? W is equal to minus P delta V. So do you find anywhere delta V here? Yes, there is a delta V. Can I say its value will become 0? Under which condition? Under isochronic condition. So therefore work done will be what? 0. Can I say this is the first time you people are saying work done 0. So under which condition? Work done value is 0. Under isochronic condition. Okay. Sometimes what happen? He will give lengthy question. He will provide all the values. Okay. He will provide isochronic process and ask you to find out work done. Without solving anything, just choose the answer 0. Okay, right, move to the next one, second one. What is the second one, Nana? So second one is nothing but delta U is equal to Q plus W. Since in isochronic process, what happened in isochronic process, work done value is what? 0. So therefore, what you can say, delta U is equal to Q. Okay, what is that? Delta U is equal to Q. So can I say this heat is supplied under which condition? Can I say heat is supplied at constant volume? So what I'm going to write? QV. So from this, there is one definition. One definition you can create. What is the definition? The heat at constant volume. The heat at constant volume is called internal energy. Internal energy. I hope you people understood. Heat at constant volume is called internal energy. Clear till here? Right. So this is very, very important. Right. Moving to the next one. The next condition, fourth condition is what? Adiabatic process. Okay. The fourth condition is what? Now, before going to fourth condition, let us take one small note. Okay, so just now you people written that delta U is equal to Q. Okay, but now what happens? Sometimes Q may be plus Q or it may be minus Q. Okay, if it is a plus Q, okay, then what happened? Delta U will be positive. If it is minus Q means what? Delta U value will be negative. That means here what happened? Energy, internal energy is nothing but energy, right? Positive means what? Energy increases. Here delta U negative indicates what? Energy decreases. Okay, under which condition energy increases? Whenever the temperature is very high, because higher the temperature the molecules become more energetic. Okay, so here when does the energy get decreases? When the temperature is low. Okay, I'll explain you again. Suppose there are molecules, okay, and you people are heating. So if you heat, what happens? This molecule will absorb energy and they become more energetic. That means higher the temperature, higher will be the energetic. Okay, so high temperature means heating process or cooling process. Can I say it is a heating process? Right? And what about low temperature indicates what? Cooling process. Cooling process. Clear till here? I hope you people understood this concept. Right, move to the next one, fourth condition. The fourth condition is what? Adiabatic process. Adiabatic process. Okay, so let us try to understand what is the meaning of word adiabatic. Okay, here you should know clearly that the heat itself is zero. Okay, the transfer of heat will be zero. Okay, now many people will say that ma'am heat is zero means actually what happens? Suppose there is a process. Okay, okay, outside 10 joules of heat is there. How much heat is transferred here? 0 joules. Okay, why heat is, that means here heat is zero indicates what? Heat transferred. Okay, amount of heat transferred is zero. Amount of heat transferred, not heat value, you can say amount of heat transferred from one side to other side. Okay, transferred is 0. Okay, let us see what is the first formula. W is equal to minus P delta V. Okay, so do you have Q in this here? Now can I say there is no Q? Okay, uh, 1 minute. Yeah, so actually this one even you can apply for the whenever you have the plus W also. Okay, there are two choices. Sometimes delta U will be work done, sometimes delta U is equal to Q also. Okay, so you can apply for both heat and work. Clear till here? Right, so that means here what happened in this case? Adiabatic process. First one is this one. Okay, second one what happened? What is the first? Second one, delta U is equal to Q plus W. Okay, can I say here Q is 0? Right, so therefore what you can write? Why Q is 0? Because adiabatic process Q is 0. So therefore what? Finally what you can say? Delta U is equal to what? Work done. Okay, now same thing you can apply here. What is that? Work done may be positive, work done may be negative. Whenever work done is positive, what you can say? Delta U is also positive. Or else you can say here what? Delta U is what? Negative. Delta U positive indicates what? More energy. Okay, like this remaining points you can write which we have written in the above case. Same thing you can follow here. Okay, heating effect and cooling effect. Okay, right, move to the next one, fifth point. So the fifth process is nothing but cyclic process. Okay, cyclic process. What is the meaning of cyclic process? The initial point and final point both are same. Okay, so what is the specialty of cyclic process? All state function or path function, state function are zero. All state function values are zero. Okay, for example, if I say delta okay, if I say delta v, 0. Okay, if I write delta t, 0. Okay, because delta v, delta t, that is volume, temperature, or else you can say internal energy, etc. All these are what? 0. Why? In cyclic process, what is the specialty of cyclic process? All state functions are 0. Clear till here? Right. So from here, let us see, let us check one by one. So first one is work done is equal to minus P delta V. Okay, now what happened? You will say that, ma'am, delta V is a cyclic process, hence its value is 0. So work done will be 0. So actually this is not correct. Okay, the formula will be as it is. Okay, the reason behind this is what? Practical concept. Okay, suppose there is a college. Okay, you people are standing here. Okay, and I will ask you to run for um, to one round. Okay, you people go here, run, and you will come to this position. That means the cycle process. Now when you come back, I will say that you people didn't did any work, you people didn't invested any energy, then you will agree with this? No. So in the same way, in cyclic process, work done will be never 0. Okay, right? Theoretically you may apply here and prove that the work done is 0, but practically the work done will be never be 0. Okay, right? Moving to the next one, second one. The second one is what? Delta u is equal to q plus w. Okay, can I say here delta u is a state function, sorry, path function, so its value is 0. So therefore finally what you can write, q is equal to minus w, or you can write w is equal to minus. Clear till here? I hope you people understood here. Right, moving to the next one note. Right. So under the note, what we people are going to study, we people are going to study that. For example, Q is what? State function or path function. Can say it is a path function, right? What about W? W is state function or path function. It is a path function. Okay. But if I write delta U is equal to Q plus W, right? What about this equation? Remember, it is what? State function. Clear till here? Always remember. Sorry, not delta U. Suppose if I write here Q plus W. Okay, not delta u. If I write q plus w, what about it? It is nothing but state function. You will say, ma'am, both are path function. No, if we add both path function, you will get path function. No, q plus w is nothing but indirectly they are representing what? Delta u, and delta u is what? State function. Clear till here? Right, moving to the next one. So the next one is nothing but enthalpy. Right, so the second basic term we are going to study, the second basic term is what? Enthalpy. Okay, and enthalpy is denoted by which letter? H letter. Okay, so let us try to understand what is the meaning of enthalpy. Enthalpy is nothing but heat present in the system. Heat present in the system. Heat present in the system at constant pressure. At constant pressure is called enthalpy. Okay, suppose for example I'm talking about one pencil. Okay, energy present inside the pencil. Okay, energy present inside the pencil is called internal energy. Okay, heat present inside the pencil at constant volume. Okay, let me explain you again. There is a pencil. Okay, so if I'm talking that energy present inside the pencil, okay, energy present inside the pencil is called internal energy. Heat present inside the pencil at constant volume is also called internal energy, because just now we have written the second definition. Okay, if I say heat present inside the pencil at constant pressure, then what you should call? Enthalpy. Okay, take this is very very important. Heat present inside the system at constant pressure is called enthalpy. Clear till here? Right, move to the next one. Let us try to understand, is a state function or path function? Obviously we have completed all these things. It is what? A path function, state function. Path functions have only two examples. What are those? Heat and work. Okay, next one, it is extensive property or intensive property. It is an extensive property. Can you find out the exact value of h? Exact value of h is not possible, but change in h value is possible. Okay, move to the next heading, formulas. Very very important. Now we are going to start the formulas of the delta h. Okay, what is the first formula? Delta h is equal to delta u plus p delta v. Okay, second formula, delta h is equal to delta u plus p delta v, or you can write it as what here? Okay, p delta v is nothing but what? Pv is equal to nRT, right? If I write p delta v is equal to what you can write here? Delta n RT. So what will be the next here? Delta n RT, which is nothing but G. Okay, now we'll say, ma'am, what is the meaning of delta G? Okay, delta Ng. What is the meaning of N here? Moles. So what it says? Number of moles of okay, wait a minute. I will write the formula. What is the formula of delta Ng? Okay, gas moles of product minus gas moles of reactant. Okay, gas moles of product minus gas moles of reactant. Okay, moving to the next one. Third formula, very rarely people are going to use delta H is equal to delta U plus P final V final minus P initial V initial. Clear till here? Very rarely you are going to use this formula, but most commonly used formulas are what? First two formulas are very important. Okay, right, moving to the next one. Fourth formula, relation between, the fourth formula is also very important, relation between delta H and delta U. Okay, so as I said, whenever delta Ng value, there are total three types of delta Ng value. Sometimes you will get positive, sometimes you will get zero, sometimes you will get negative values. Okay, positive value indicates what? Can I say positive value is nothing but greater than zero. Okay, this you can call it as equal to zero, or this you can call it as what? Less than zero. Okay, whenever the positive is there. Okay, so remember, left side must be delta H, right side must be delta U. Delta H, delta U. Okay, delta H, delta U. Okay, this position should be constant because this is a trick to remember. Okay, so now what happened? Positive indicates what? Greater than symbol. Zero indicates what? Equal to symbol. Negative indicates what? Less than symbol. So this is the relation between what? Delta H and delta U. How to find out the relation between delta H and delta U? By using what? Delta Ng. Clear till here? Right, moving to the next one. The next one is nothing but as second point, fifth point. Okay, it's not about fifth point, just write it as a note. Okay, so whenever you see the word vacuum, okay, whenever you see the word vacuum, or whenever you see the word free expansion, free expansion. Okay, what is the meaning of this word? They are saying that indirectly they will say that pressure value is zero. Pressure is not, I'm not talking about constant. There is a lot of difference between pressure is constant and pressure is zero. Okay, in isobaric process pressure is constant. In vacuum process pressure is zero. So let us see work done. Work done is equal to minus P delta V. Can I say here P is 0, right? So finally what you can say, work done is also equal to 0. So from this, work done is equal to 0 under which condition? One is under isochoric process. Okay. And second one under which condition? One is vacuum. And third one is what? Free expansion. Whenever you see these three words in the question, immediately you should say work done will be 0. Clear it here? Right, move to the next one. The next concept is nothing but our heat. As I said, we are going to study heat related, right? Types of heat related. So there are total three types of heat, right? What are those? Heat capacity, molar heat capacity, okay, specific heat capacity. So heat capacity is regarding what? Okay, let us try to understand what is heat capacity. Okay, now what happened here in this case? For example, I'm going to take three beakers. Okay, for three experiment, specific heat capacity, sorry, it's denoted by only S. Okay, small s. Right, now what happened here? I'm going to take the sample of water. Okay, so okay, here what I'm going to do, I'm going to take some x amount x grams of water. Okay, here what I'm going to do, I'm going to take 1 mole of water. Okay, here what I'm going to do, I'm going to take 1 gram of water. So we are doing three experiments. X grams of water, that is unknown amount of water, 1 mole of water, 1 gram of water. Okay, now what happens? Suppose its temperature is what? Before it was 25 degrees Celsius. Okay, you want to convert to 26 degrees Celsius. Okay, now here the temperature is how much? 25 degrees Celsius, 25 degrees Celsius and 25 degrees Celsius. What happened? You people want to convert from 25 to 26. That means you want to increase by 1 degree Celsius. Everywhere you want to increase by what? 1 degree Celsius. So generally, how to increase 1 degree Celsius? How to increase the temperature? You people have to supply what? You people have to supply the heat. Okay, when you supply the heat, what happened? It increases the temperature. Okay, so here the amount of heat supplied is called heat capacity. So here also, to increase 1 degree Celsius, you have to supply some heat. Okay, you have to supply some heat, and this heat we should call it as what? Molar heat capacity. Here also, to increase 1 degree Celsius, what you have to do? You have to supply some heat. Okay, this heat supplied amount is nothing but specific. So what is the main difference between everyone? Can I say amount is different? Okay. So what you can say here, heat capacity definition is what? Heat required to raise 1 degree Celsius of unknown amount of water. Here, heat required to increase 1 degree Celsius for 1 mole of water. What is the third definition? Heat required to increase 1 degree Celsius for 1 gram of water. Okay. Not only water, you can take any other compounds. Okay. I hope you people understood the differences between the heat capacity, molar heat capacity, and specific heat capacity. Okay, now let us try to write down the formulas one by one. Right, so first formula is what? Heat capacity. Okay, heat capacity. Okay, so generally heat capacity is denoted by which letter? C. So the formula for heat capacity, C is equal to Q by delta T. Okay, what is the formula of heat capacity? C is equal to Q by delta T. Okay, then what will be its units? Heat is nothing but energy. As I said in the starting, heat energy both are same. So what do I have to take? Joules by joules into can I say joules per Kelvin or joules into Kelvin inverse. You can take calories per Kelvin, etc. Whatever you want, you can take degree Celsius, etc. Okay, right. Move to the next second one. Second one is nothing but what? Molar heat capacity. Molar heat capacity. Okay, so molar heat capacity is denoted by which letter? Cm. Okay, so here Cm is nothing but heat capacity is what? Okay, heat capacity is Q by delta T. Okay, molar heat capacity is what? N delta T, not M. Okay, since you're talking about molar, we are going to take what? N here. Here N indicates what? Mole. Okay, right. So this is what, Anna? This is our molar heat capacity. Clear till here? Right. So just before going to this, let me explain you. This heat capacity is further divided into two types. Okay, heat capacity at constant pressure, heat capacity at constant volume. Okay, so just give me some time, just give some space. Okay, so you people are going to study two types of formula here. One is at constant volume, other one is at a constant pressure. Okay, suppose if I'm writing Q. Okay, so what you can write here? Q is equal to C into delta T. So since we are talking about constant volume, so what you will write? QV is equal to CV into delta T. At constant pressure, QP is equal to CP into delta T. Okay, so from this what you can write? We can also write that QV is nothing but heat at constant volume. Heat at constant volume is nothing but what? Internal energy. So internal energy is equal to CV into delta T. You can say internal energy gets second formula. What is the first formula of internal energy? Delta U is equal to Q plus W. What is the second formula of internal energy? CV into delta T. What is the meaning of CV? Heat capacity at constant volume. Next here, heat at constant pressure is nothing but enthalpy, which is nothing but delta H is equal to Cp into delta T. I hope you people got the clarity. Right. So by using this, what is the relation between Cp and Cv? Okay, Cp and Cv later we are going to study. First of all, you people have to learn till here. Okay. Right. So if, okay, or else I will write here itself. Okay, so what is the relation between Cp and Cv? The relation between Cp and Cv is what? Cp minus Cv, sorry, Cp minus Cv, sorry. Okay, so from here by combining this, what you will get? Relation between Cp and Cv. Okay, so what are the formulas between Cp and Cv? The first formula is what? Cp is equal to, okay, we can Cp minus Cv is equal to R. Okay, and what about the second formula? Second formula is Cp by Cv is equal to gamma. Okay, so now the question is, ma'am, what is the meaning of this gamma? Okay, the gamma is nothing but what? What you should call this gamma? Gamma is nothing but Poisson's ratio. What you should call Poisson's ratio. So what is the purpose of studying this Poisson's ratio? Okay, this Poisson's ratio gives us information regarding what? It gives information about atomicity. What is the purpose of studying Poisson's ratio? It gives us information about what? Atomicity. Okay, atomicity information you are going to get. Now you will say, ma'am, how we will get, how we'll know that the gamma value will give us the atomicity? Okay, let me draw one small tabular form. Okay, right. So monoatomic, okay, diatomic, and last one is what? Polyatomic. Polyatomic, monoatomic. Okay, when you should say the monoatomic, okay, if the gamma values, okay, if the gamma value is how much? If the gamma value is 1.66, monoatomic. If the gamma value is 1.4, then diatomic. If the gamma value is 1.33, then you should say polyatomic. Clear till here? Based on gamma value, you can decide. Or else, instead of writing 1.66, you can use 5 by 3. Instead of 1.4, you will get 7 by 5. Instead of 1.33, you can call it as a 4 by 3. Clear till here? But my suggestion is better you remember these values. Because 5 by 3 is nothing but 1.66. 7 by 5 is nothing but 1. Clear till here? Right, so this is all about what this is completely regarding what our heat capacity. Okay, so this is completely regarding our heat capacity. Now we are going to start with molar heat capacity. As you people know, what is the meaning of molar heat capacity? Heat capacity for 1 mole of substance. Okay, right, next one, coming to its units. Okay, so coming to here, units of molar heat capacity. So units is nothing but and q is nothing but heat indicate what? Joules. Okay, joules into mole, that is nothing but mole inverse into Kelvin inverse. So this is the units of what? Molar heat capacity. Next, third one is what? Specific heat capacity. Specific heat capacity. Okay, specific heat capacity is denoted by which letter? S letter. Okay, now what is the formula for specific heat capacity? S is equal to q by m into delta t. What is that formula? S is equal to q by m into delta t. Now I will say, ma'am, what is the meaning of m? M is not a molar mass, it is a given mass. It is what? Given mass. Okay, so in this formula, what will be the units? Right, q is nothing but energy means joules, into gram inverse into Kelvin inverse. Clear till here? Right, move to the next one, relation between heat capacity and specific heat capacity. Okay, so write down one note under the note. What is that? Heat capacity is equal to specific heat capacity into capital M. Okay, here what does a capital M indicates? Molar mass. Molar mass. Clear till here? I hope you people got clarity what I'm trying to say, right? So this is nothing but our what? Almost 40% we have done, right? Remaining part we'll discuss in the next video.